morning, everyone. Let's start. In previous class, we started discussing data types, right? Data types in Hive. So in this, we started discussing simple data types, simple data types, simple data types, simple data types, and we started discussing complex data types, complex data types. Okay. So simple data types for every Java data type, for every Java data type, we see equivalent Hive data type, right? Hive data type, Hive data types plus Hive has Hive has some additional uh, simple data types, right? Simple data types. So we seen some examples related to simple data types. Next, we have complex data types. So complex data types are array, map, struct. So in previous class we seen array, we seen map, right? So yesterday class we discussed both array and map. Let's start continuation of complex data types. So let's start structure data type. So when we go for structure data type means, see, if you take array can store collection of elements, right? Array can store collection of elements of same type. Yes or no? Same type. So we call it as homogeneous elements. Homogeneous elements. Homogeneous elements. In a single variable, we can store collection of elements. In a single variable, we can store collection of elements of same type. I want to store different type of data. I want to store different type of data in a single variable. I want to store different type of data. So it is not possible. It is not possible. It is not possible to store different type of data. Different type of data. So we call heterogeneous. 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 Heterogeneous data into a single variable. Into a single variable using array, right? So to store heterogeneous data, we use struct. To store heterogeneous data, we use struct. Simply we can say, so struct is a solution to resolve the problems of array. In our Hive, struct is a solution to resolve the problems of array. Struct is used to store multiple values of different types. multiple values of different types. Example, I want to store I want to store person details person details with wife details person, and in one column I want to store complete details of wife. In a single column I have a person with multiple columns. One column I want to store complete details of wife. So for that column we define structure wife as a structure. So wife is complex data structure, right? Data type. So that's why we are using complex. So Cloudera. So let's create cat profile. So in this profile, I am creating multiple people profile. So first person is, wife is, wife location, and person location. So I'm creating some data. I'm creating some data. So person is, name, wife is, wife location, and person location. Okay. So control D. Let's start high. So this one, let's start high. Yep, delimiter for row format delimiter, we are using comma, right? And collection items, hash. So still Cloudera mission is in starting. So once it is successfully started, it will start all demands so that we can able to connect Hive. So started connecting Hive. Yep. So we just started discussing structured data type. Structured data type. Yesterday we discussed all these data types, right? So we discussed simple data types in yesterday class, and we started discussing complex data type. As part of complex data types, yesterday we discussed both array and map, right? So today we are continuing structured data type. So structured data type, array can hold collection of same type of data. If you want to store different data in a single variable, we go for struct. Okay, struct is a data type, is used to store multiple values of different types. Okay, we created one profile with multiple columns. In this column we have person details and wife details. So person details are separated with delimiter comma, and wife details are separated with hash. So we are storing this complete wife details in a single column. In that column uh, we are using structured data type. For that column we are using structured data type. Okay, so let's start. So how we started? So create a table, create table. So before that, use database, use MyDB, show tables. So we have earlier we have emp, ext and student trans. Let's create a table. Table name, table name is profile, and this profile table, first I am taking person name, person name simple type. Next one, person age, simple type int. Next, wife, wife data type is complex data type. Struct. So in this struct, again wife has name colon string comma. Next one is colon int comma. Next one, location colon string, okay, comma. Next, location of person string. This is table creation structure is not dependent upon data, right? So first this table creation we do one time, yes or no? But data loading we do multiple times. So this data table creation structure happens only one time. So while creating, we have to know what are the columns presented and what is the data type. Okay. So table is created. Let's display the structure of a table. Describe table name profile. So this one, it's saying person name is string type, age is int type, wife is struct. Again, this struct can have multiple columns and location struct. So I think you did not observe our data. So if you observe this data, person location is separated with comma. This is complete wife details. So collection items are separated with hash. Yep. So we are storing this complete details into structured data type. Let's load this data. Load data local in path, local in path, and file name is profile into table, into table profile. So we are loading local file into Hive table. We are loading data into Hive table. Press enter. Next, select star from, select star from profile. So we got data, but the problem here is what will happen? No, because while creating table, we did not specify delimiter type, right? So we have to specify that one. Let's drop table, table name is profile. So let's create table, row format delimited fields, row format delimited fields, terminated by terminated by comma. Collection items terminated by hash. For arrays, for structure we use collection items. For map we use one more extra statement, keys terminated. Okay, only map we use one more statement, but both arrays and struct we use collection items terminated by hash. Let's press enter and once again load data. Let's execute select statement. Okay, so let's see one more difference here. If you observe, we are executing select statement, right? We are executing simple select statement. I said for every statement internally MapReduce executes, right? For every statement internally MapReduce program will execute. But here if you execute select statement, we are getting response very faster. Let's use condition part. Select star from emp and where a is equal to 24. Press enter. So this is also very simple. Let's write this data contains sample data, that's why we cannot see any difference. Let's see how to access employee person name and wife name. Person name and wife name. Wife name is presented in structure. So structured data is represented in this form. So I want to display person name and wife name. Tell me how to display. Select person name. So wife is a structure, right? What is the structure name? Wife. And in that structure we have variable name. So structure variables we can access with data. Array variables we can access using index. Structure next to map variables we access. Map values we access by using keys. Okay. Structure variables we access structure reference dot variable name. From profile. Yep. Let's take some sample data. So next we are going to discuss order by. So to give clear clarity on this order by, let's take some sample data. So 101 employee name, 102 employee name, next 103 some employee name, and salary I am taking 20,000 and male, and department I am taking 12. So 104 I am taking one more employee name AA and salary is 40,000 and department number is 12. Female, department number is 12. I am taking 105 employee name XYZ and salary is 20,000 and gender is male and department number 11. So here I am taking instead of XYZ, so before yes some PP. Next, I'm taking one more employee, 106. 106, I'm taking ABC, taking female. Salary is 50,000. 50,000, female, and department number 13. So let's create employee file. So already I think we have an employee file. So let's override that data. So cat greater than emp. So if you use this operator, emp, it will append the data. It will append the data. Means if employee file is already available in Linux, it will append old data with our new data. So if you use this operator, it will override. If already employee file is available, it will override. Okay, let's open our Hive, show tables. So we have already employee table. Let's select star from EMP. I want to remove all the rows of employee table. Instead of dropping table, I want to use same table. I want to remove complete data. Can anyone tell me how to remove data? Table, employee table. Tell me how to drop data. If delete from table name is EMP. That's it. Sure. Okay, let's use one more condition where EMP NO greater than 0. Still, we are getting error. So, yep, update and delete is not possible in our Hive. But to perform update and delete, we use some option. Let me check option here. In Hive, default delete and update is not possible. So before delete and update, we have to execute one more option. How to delete rows in Hive. In latest version from 0.11 onwards, delete option is available. So let's go to Stack Overflow. Here we execute one option. We add one option. Let me see. Delete from table where expression. No. Command we can use in any. We need to use one option. Let me check. Yep, I think this one. Hive dot support dot concurrence equal to true. We have to do before uh, opening our Hive console. We have to do this one. So this is permanent way of setting, and temporary way of setting we use command. Let me check command. Yep. Let's now execute delete command. Still same. There is some other option. Let me check. Let's use this syntax. We can use other command also. So instead of this one, no, drop will drop everything. Complete table structure also. I'll show that option tomorrow. Let's use different approach to remove data. So I'm using command. See different command. Insert overwrite. Insert overwrite table. Same table EMP. Insert overwrite table EMP. select star from EMP where EMP number EMPNO less than 0. So there is no record with the EMP number less than 0, right? So there is no records are selected. It empty data is going to overwrite into EMP blank data. Okay. In this way we can do insert override spelling, insert override, override, insert override table EMP, insert override, then insert override, no, table name, insert override is not recognizing. Yep, that is not recognizing. Let's see. Yep, earlier we write maybe command is different. No, we can write anything. Select option, we can write anything. But this time it is reading complete data and storing into same. So let's use select insert override table EMP, select star from EMP where employee number less than 0. Let's use employee number equal to 0. Select star from, spelling is correct. Yep. Spelling mistake. Yep. All conditions will work. Only one thing we missed T. We are overwriting into existed table with some condition, but there is no row match, right? So that's why we get empty data is going to store into EMP. So there is no data. Now let's load data local in path, and file name is EMP into spelling mistakes into table EMP. So we loaded data into EMP. Select star from EMP. So we got the data. Yep. Next, order by command. Order by arranges data in either ascending or descending order. Descending order. Default is ascending. Default is ascending. Default is ascending. It will arranges data in either ascending or descending order. Okay, but default is ascending order. Numeric data. If it is a numeric, if it is a numeric, lower to higher. If it is a alphabet, then instead of alphabet, if it is a string data, then alphabetical order. Alphabetical order. So order by arranges data. If it is a numeric column, we pass order by, then it will arranges data from lower to higher. If it is a string, alphabetical order. Let's see. Select star from EMP. Order by. I'm giving E name. E name is alphabetical order, means first we get ABC. A, A. Next ABC. So in this way we get alphabetical order, ascending order. So this internally converting MapReduce application. So simple select queries execute very faster. If you use any conditions, it will take little time, because internally it has to generate mapper, right? Mapper. So earlier we developed a MapReduce application. In mapper we generated key value pairs, right? So here what is the key? Key is employee name. Entire value list is complete table, selection list, complete employee row. Employee row is value list. Yep. No. So you are saying 10,000 records, RDBMS executes faster but Hive takes time. No, it's wrong. So we are running in a simple mission here, single mission. So if it is a cluster mode, we have multiple missions, right? So multiple missions, your data is going to process parallelly. Here we are running in a single mission, that's why we are not seeing any difference here. But if you run same query in cluster mode, you will see clear difference. Okay. And one more important to note is Hive queries. Write this note. Hive queries. Hive queries means SQL, right? SQL. By default, by default runs in MapReduce mode. By default, it runs in MapReduce mode. We can change MapReduce mode to Tez mode. Tez mode. So Tez is a new mechanism. For us, new mechanism, but it is already existed. Tez is a new mechanism. It will run queries very faster. Sorry. It will run queries very faster. Tez actually, it is a Hindi word. So Tez means fast, right? So Apache are borrowed this word from Hindi, and they designed Tez mechanism. And we can also run also run Hive queries in Spark mechanism. Spark mechanism. So Spark is super fast, right? Spark is super fast first. So we can do like Spark and Hive integration, Spark and Hive integration, Spark and Hive integration. Then you can write SQL queries. That SQL queries runs in a Spark environment and converts into Spark programs so that they execute very faster. So we have multiple ways to run Hive queries. You can run default mode MapReduce. You can change default mode to These mechanism. So Hive has one hive-site.xml file, hive-site.xml file. Here you can modify one property. You can modify one property. So find in Google and modify property to These mechanism so that your queries are executes very faster. And if you integrate Hive with Spark, they are execute very faster. Same Hive queries. Yep. No. Word. Word is from they taken in the word. These is in the word. No. Word name. They given name These. Yep. Only here we did modification. We never change any query. Query is same. But internally, if you modify property here, the execution become faster. And if you write the same query with the Hive, Spark, it executes very faster. Yep. Or you can install Spark separately, write Hive query, integrate Spark with Hadoop. Then so Spark programs we run in this way. We write Spark applications. We write Spark applications, and we can run the Spark applications on run Spark applications on standalone cluster. Standalone cluster. So we can create standalone Spark master slave cluster. Spark master slave master slave master slave architecture. Next one, we can run same Spark application on Yarn cluster. Yarn cluster, and we can run on Mesos cluster. So same Spark application we can run on multiple environment. So in this Spark application, we return Spark and Hive integration. If we run this one with Yarn cluster means Hadoop environment. We develop a Spark application, we convert into jar file, and we submit this jar file to Yarn cluster. Yarn cluster. Then Yarn cluster process your Spark application means internally your Hive queries are converted to Spark applications and executes faster. So if you feel MapReduce environment taking more time, change to These or integrate Hive with Spark. Integrate Hive with Spark, your queries executes very faster. Very faster. Cloudera. So this one may be any. This one may be any. It may be Cloudera, it may be Hortonworks, it may be any vendor. So we write the Spark applications using Scala or Java or Python. Then we deploy this application into any vendor cluster. Apache Hadoop cluster or Hortonworks cluster or Cloudera cluster or Mapper cluster or Amazon EMR or Microsoft HD Insights. So now we see only two vendors, Cloudera and Hortonworks is merged. So we cannot see two different vendors now. So both formed. And next we have competitor is mapper. So next one, Amazon EMR, and next one IBM Big Insights, and next one Microsoft HD Insights. So we have multiple vendors. So these are popular vendors of Hadoop. So Apache Hadoop, on top of Apache Hadoop, these are different vendors available in the market. There are some others. These are popular vendors. So earlier we discussed Cloudera, Hortonworks separate vendor, but today they both are merged. So I said go to, so one of our friend asking how to change MapReduce to this. Go to high-site.xml file and first find high-site.xml file details. Search high-site.xml file. There search Tej property. Okay, Tej property and change in installation path. Hive installation path. Yep. So we got data based on name. We got data, right? So based on name column, it is arranged the data by default in ascending order. If you want to descending order, here we use order by name DESC. DESC. Total time it is saying 32 seconds. 32 seconds. By using partition concept, we can reduce this time. So descending order based on name, it is displayed descending order. Next one, this is single column. I want to use multi-column. 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 I think I didn't use multi. Hmm. Let's create one more column, one more file with same data, different data. Let's use 107 and name is same. Name is same, but salary is different and department number is different. Name is same, department number is different, and this one is 107 and I'm taking 108. Name is same, salary is same, department number is, salary is different, department number same. I'm taking 108. 108. Name is, I'm taking different name, but salary is same, gender is same, department number is same. Different scenarios I'm taking. First scenario, name is same, salary is different, right? Salary different, department different, gender is same. Name is same, salary is different, department number is same. This one, name is different, salary is different, department number same. Let's take one more. Name is same, age, salary is same, gender is same, department number is different. So let's take these values and create one more file. So cat emp2, this is the data, control D, and place this file into our EMP table. Tell me Hadoop command to place this file. Hadoop fs -put emp2 under root under user under hive. Tell me under warehouse under my db.db. In this EMP table is available, right? Press enter. So let's go here. Select star from EMP. Okay. So we have data. So we are displaying data based on name. Let's see. Select a star from employee name. I'm using first single column. I'm using single column. So single column means based on the alphabets. So AA. So both the salaries are same. Gender is same. Department number is different. I want to use multi-column here. Department number. If I use multi-column, so employee name is same. Next, if both employee names are same, it will comes to second column. Then second column is numeric, right? So numeric means which one comes first? This is default ascending order. In that case, 12. So first record comes AA 40,000 female 12. Next record comes AA 40,000 female 14. Let's execute this one and observe the clear difference. Okay. So first AA with department number 12, AA with department number 14 is came next. So if you use multi-column, first it will take first column and compares with other records of same table. If any table which has same name, then it will consider second name, second column. Second column is numeric, then it will comes in ascending order. You can give in this order also. This one, let me take another. So here if you observe, both employees names are same, department number is same, and I want to display based on their salary. Then you can use one more column sal. So sal I want descending order. These two I did not specify any order, right? Then these two columns it will apply ascending order. So ascending order means, so both Swati comes same, no change. Coming to department number, there is no change. But Sal descending order. So 40,000 comes first, 30,000 comes next. Let's take another. Let's coming to this one. So here also we have a same data, right? Same data. Let's update this data. So before executing this command, let's update 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 EMP, right? Update EMP set 108, right? Set sal equal to 30,000 30,000 where EMPNO equal to EMPNO equal to 108 and department number equal to 14, because 108 records are multiple 108 records are there. So that's why I am using this command. So by default this is not supported, update one. Then we use yep, the problem is update issue, right? So we have to enable that property. So we did not enable that property, that's why we are unable to execute update command. Yep. So we'll discuss that update command tomorrow. So before that, let's check, is there any other record to compare? So here we have different names. Yeah, let's take here. Srinivasa is a name. Same name, but salaries are different. Department numbers are different. Let's use select star from EMP order by e-name. E-names means, assume, let's consider this one. E-name comes in same order. Srinivasa, same ascending order. So next both are same. Next one, sal, sorry, department number. Department number ascending order means, so first 11 record first comes, next one 13th department number, next sal is descending order. Sal is descending order. It means if you observe it, consider these two records. So coming to name, both are in same. Next, if both are in same, it will comes to next column. Next column, department number. Department number we did not specify any option, that's why it will consider ascending order. So already these two are in ascending order. Next it comes to next column. Next column we are saying salary column descending order. So if you sorry, salary column descending order means, so 30,000 record comes first, next 20,000 record comes next. Okay, let's execute this one. Observe the two records. Yep. So first one, employee, and next one, department number 11. Let's once again see, salary is descending order. So coming to first column, employee number. Yep, it is also considering this one also. This one is in ascending order, right? Mm, yep, DESC. Let's apply DESC. So highway displayed correct output. Our analysis is wrong, right? So department number in ascending order. If two departments has same salary, then next column. Okay, this time it displays correct output. Srinivasa 30,000 and 20,000. So second column also important. In second column, if there is another Srinivas with department 11, in that case it will consider. Okay. So order by we can apply multiple columns, and tomorrow class we are going to see aggregation operations. Aggregation. Yep. Yeah, we'll discuss that one. Aggregation operations. Aggregation operations we'll discuss. Next, we'll discuss, if possible, we'll discuss joins. Joins tomorrow. Okay. So Saturday, Saturday and Sunday from 9 to 1. 9 to 1. And Saturday, Sunday, I'm planning to finish our uh, Hadoop course. Hadoop. Monday, we are planning NoSQL database. NoSQL. As part of NoSQL, we are going to discuss Cassandra and HBase. Cassandra and HBase. 5 hours for Cassandra and 5 hours for HBase with Java integration. With Java integration, Java integration with Java integration with uh, Cassandra, Java integration with HBase. So after that, try whoever knowing other language like Python, convert these Java programs to Python programs. So I think JDBC or ODBC drivers are available. JDBC and ODBC drivers are available for both Cassandra and HBase. You can, whichever driver is supporting for Python, use that corresponding driver. So the way I'm going to use driver in Java application, you can use same syntax for Python. Then say I worked on Python with Cassandra, Python with HBase. Okay. No, let's finish first this one because it requires 5 hours. Okay, that's it for today, and we'll meet tomorrow. We'll continue aggregation operations in Hive. Okay, timings are for this Cassandra at basis same time.